We're in the middle of talking about the comparison test, so it's a good guess that the comparison test will work here. But just as a quick review, let's think about the other tests that we've learned. We started with the divergence test. We take the limit of the sequence terms that are being added, and we find that this is 0. So this is inconclusive. The divergence test doesn't tell us whether this converges or diverges. We could try to do the ratio test. If we computed the limit as n goes to infinity of the ratio of consecutive terms, we would get 1. And again, this is inconclusive. If we tried the ratio test, our conclusion would be try another test. We could do the integral test. This integrand is positive, continuous, and decreasing, but to integrate it, we'd probably have to start by completing the square, and there might be an arctangent. So this will work, but it'll be messy. So indeed, this is an excellent candidate for the direct convergence test. This is my mystery series, so its terms are what we were calling ANs in the statement of the direct comparison test. I need to compare this to a series whose convergence is known. And my intuition is going to take me to the following place. This denominator is a quadratic function, and I'm concerned with what happens when n is quite large. When n is quite large, this highest degree power really dominates. So I'm going to take Bn to be the terms I get when I just delete these lower order terms in the denominator. I can factor out 5/2, and then I'm just left with a p series. P is equal to 2, that's bigger than 1, so my B series converges. If I want to compare AN and BN, I need to make sure that the inequality goes in the correct way. So which of these is bigger, AN or BN? AN has a bigger denominator, so its terms are smaller overall. Now let's compare this to the divergence test. My BNs converge, and my ANs are smaller. That's the coupling we want, so we get to conclude that our mystery series, in fact, converges. When you're showing something using the comparison test, you always need these two pieces. You need to show that the inequality goes the right way, and you need to show whether your B series converges or diverges. Let's visualize what we just concluded. The series that we knew about converges, so we think of the terms being added as small. They're small enough that even when I add up infinitely many, that sum is finite. The terms in my mystery series are even smaller. So if the terms on the left aren't big enough to sum to infinity, certainly the terms on the right aren't big enough to sum to infinity either. So the mystery series converges. Here's a second example. This is another good candidate for the comparison test. It would also be an okay candidate for the integral test. You could integrate using a pretty simple u substitution, but direct comparison is going to be a little faster. A series that I know about is the harmonic series. This series diverges. So I'm going to let my BNs be 1 over n. My ANs, those are the terms that I want to know about. Those are log n's over n's. And if n is bigger than e, then the natural log of n is bigger than 1. So for large values of n's, my a sub n's are bigger. Remember, for series convergence, we never stress out too much about the first couple terms of the series. They never have much of an impact. If we go back to the text of the direct comparison test, that's exactly the connection we want. Our BNs diverge and our BNs are smaller. So by the direct comparison test, our mystery series diverges. If we want to visualize what's going on, because the harmonic series is divergent, we imagine that the terms being added up are big. Most of the terms of my mystery series are bigger than the terms of the harmonic series. Not the first few, but pretty soon they become bigger. If the stack on the left has terms so big that it climbs up to infinity, certainly the stack on the right climbs up to infinity as well. That's why we can conclude that the series we're asked about diverges as well. Now in this question we were given the series on the right and we came up with the series on the left. Choosing a series is going to be a topic of a later video.